Eelgrass meadows are important ecosystems that can be found along coastlines all over the world. To pick just one reason why they're important, they provide very good fish habitat. The impetus for this study is that a lot of conservation groups are tasked with promoting the longevity of eelgrass meadows amidst human stressors, and that can mean providing protective areas or requiring mitigation for offsetting losses that happen due to human activities. And that's a tricky task because eelgrass meadows move a little bit from year to year. For this study, we put together a pretty interesting data set. Over the past century or so, people have been mapping eelgrass meadows in ecosystems along the west coast of North America. We put together as many of these maps as we could find. This was nice because it gave us a long-term time perspective that a lot of times in management contexts we don't have access to. By taking a long-term look at these changes over time, we could see how eelgrass meadows were able to presumably take advantage of unpredictable opportunities and weather disasters that felled them. And this is important because this is probably how these ecosystems function in nature, by having different parts of their seascape having opportunities and disasters that the eelgrass meadows respond to differentially. The main findings of our study were that we found that eelgrass dynamics were asynchronous across space. And what that could mean is that within seascapes, there would be parts that might have increasing trends while others had decreasing trends, and so those changes would offset each other. Or there might be situations where an entire seascape's eelgrass collapsed, except for one little area that seemed to compartmentalize that collapse. And then we also sometimes saw really large shifts over space, so on the order of tens of kilometers. And what that means is, from a conservation implications perspective, we need to consider the full potential for seascapes to support different configurations of eelgrass meadows, not just what's present today. And it also means that it's really hard to prioritize from a conservation perspective certain areas over others because we don't know what their potential is over the long term. One of the key conservation implications for this study is that we need to consider how seascapes can potentially support eelgrass meadows instead of just how they do in a given moment in time. And also that the diversity of habitats tend to lend itself to these asynchronous dynamics that promote persistence. And so two things that we could do to better conserve eelgrass meadows would be to conserve a diverse portfolio of habitats across seascapes, and then also to assign value, for instance, in compensatory mitigation contexts, to places that don't have eelgrass meadows right now, but that could easily have some in the future. These results were about eelgrass meadows, but they should be generalizable to other ecosystems like coral reefs or kelp forests that are dynamic and hierarchically organized. From a basic ecology perspective, ecosystems persist over the long term by weathering localized disasters and taking advantage of localized opportunities. So ecosystems are always in states of flux. And from a conservation perspective, the idea is to keep habitat options open over the long term.